so let's look at section 4.4. We have problems 7, 13, and 47. Let's see what 7 is asking for. 7, saying, book wants us to find the period of the function and use the language of transformations to describe how the graph of the function is related to the graph y equals cosine x. They want us to take our function and compare it to y equals cosine x. And the function we're given is y equals cosine 3x. Okay, well, we know y equals cosine x. We've looked at that graph before in class. We know some of the basic properties. We know that the amplitude is going to be 1 and that the period is going to be 2 pi. Well, with the graph of y equals cosine 3x, the amplitude here is still 1. We've not stretched the function out vertically at all. So the amplitude is still 1, but the period is going to be 2 pi over the b value, which is 3. So 3, that's the b value. And our formula for period is that the period equals 2 pi over b. So it looks like the period's 2 pi over 3. So what that's saying is that for cosine of x, the graph, we would have to go from 0 to 2 pi, plot all those x values to see one complete cycle of the graph. But with y equals cosine of 3x, between 0 and 2 pi, the graph will complete 3 full cycles, because the period is only 2 pi over 3, which is 120 degrees. So since the period is a third of the period of cosine of x, the graph will be repeating much more quickly. So that takes care of 7. There was no other vertical shifts or horizontal shifts. It was just that the period changed. So let's look at question 13.
I know, I haven't even gotten that far yet.
Just Mr. Giorsi in the background coming into the room here. So our new function is y equals 3 sine of x over 2. Oh, and I wrote down y equals cosine of x because I thought it was the same directions, but our directions have changed. We now want to find the amplitude, period, and frequency, and then sketch a graph. So I do not need the y equals cosine x for number 13. Okay, so I'm just using this 3 sine of x over 2. Know the amplitude is going to be 3. It's got that coefficient of 3 out in front. The period is going to be 2 pi over 1/2, because it's x over 2, which is the same thing as saying 1/2 x. So my b value is 1/2. So the period is 2 pi over 1/2, which equals 4 pi. So there's my amplitude and period. Now I'm going to sketch one cycle of this graph. So there's one cycle, 0. So my amp is 3. So I'm just going to plot out a sine graph nice and neatly and then label in my scale. So I'm going to get a point at 0, 0. Max up here with the max value of 3. Back down to the x-axis. Go down to a minimum of -3. Back up to the x-axis. So there's one cycle of my sine graph. And now I want to label the x scale here. I've already labeled my y scale using that amplitude. So to label the x scale, well, the period is 4 pi, so starting from 0, I saw one complete cycle, so that means this fourth tick mark here should be labeled 4 pi. So that means it looks like each tick mark on the graph will be 4 pi divided by 4, which is just pi. So now I could figure out what any of those points are, and I could draw another cycle if I wanted to, because I could just go out to 8 pi on the x-axis, and I could just draw one more cycle. So usually I'll just sketch maybe one cycle or maybe 2 cycles, just to get a feel for what the graph looks like. Similarly, I could make the scale go back to negative 4 pi on the x-axis, draw a cycle going off to the left of the origin. So I just want to get one cycle in there of that sine graph. Let's see what 47 is asking us for. 47, describe the transformations required to obtain the graph of the given function from a basic trig function. So kind of like number 7. So our basic trig function is going to be, again, cosine of x. And the new trig function they're giving us is 3 cosine 2 pi over 3x. Okay, so I know the basic properties of cosine. The amplitude is 1, and the period is 2 pi. Well, here, for my new function, my amplitude is 3, and the period is going to be 2 pi over 3. So I'm going to actually work this out. So it's 2 pi times the reciprocal of the denominator, which would be 3 over 2 pi. The 2 pi's would cancel, so the period here is just 3. So notice I'm working out that I'm doing 2 pi divided by 2 pi divided by 3 by doing a little keep change flip. So I do 2 pi multiplied by the reciprocal, which is 3 over 2 pi. So some of your teachers in the past may have used that slogan, that keep change flip slogan. You'll hear me occasionally say that in class when I'm dividing some fractions. Okay. So I know the amplitude and I know the period. So if I want to describe the transformations to get from this function over to this function, I would have to do a vertical stretch by a factor of 3 to get that amp from 1 to 3. And then the period is going from 2 pi to 3. So 2 pi is about 6.28. So it looks like I am shrinking the period by a factor of 2 pi over 3. So I'm going to do a horizontal shrink by a factor of 2 pi over 3, because I shrunk down the period from about 6.28 to about 3.